Hi, folks. Welcome back to another episode of Emergence Tech Talks. And I'm thrilled to be back with the folks from Emergence who have recently been doing a lot of awesome work on data analysis agents and text-to-SQL. And they've put out some great blog posts and benchmarks in that space. And that's what we want to talk about today. But my name is Vivek Haldar. I'll be your host today. Let's go around the room and do some quick introductions before we dive in.
Hi, I'm Pralhad. I'm joining you today from Singapore. I've been with Emergence for about 6 months, and I'm a computer scientist by training. Enjoying my time doing AI stuff now.
Hi, I'm Ayan. I'm a staff scientist here at Emergence AI, and I've been in the company for almost 5 years now. And I've been working on different AI endeavors here at Emergence AI. And yeah, we are here to talk about the most exciting one that we are involved in recently, which is text-to-SQL and data readiness. Thank you.
Paul Haley here. I've been with Emergence for about 8 years, and I'm a fellow here.
Hi, I'm Jeremy. I'm a research engineer at Emergence, and I have worked on SQL generation as well as a bunch of other stuff with these folks.
All right, fantastic. Good to be back with everyone. And so the thing we want to talk about today is data analysis agents. And of course, a key part of that is text-to-SQL. I know you all have been doing a lot of work in it. Of course, benchmarking is a very important part of it. And you've done a lot of great work in benchmarking text-to-SQL as well. So we'll get into that. But before we get into all those details, let's try to set the stage a little bit. Can you talk about why text-to-SQL is such a fundamental capability for agents today? Why are we even worried about text-to-SQL?
Well, if you're going to do almost anything in the enterprise, you're going to be using data. And the vast majority of that data resides in SQL databases. So it's necessary, perhaps not sufficient, it's necessary that any AI that's going to work in the enterprise be able to at least access data residing in SQL databases. It's pretty much that simple.
Yeah, that makes sense. So a naive question might be, we all see how great the latest frontier models are at coding. They've been great at coding for a while now. So surely they must be pretty good at text to SQL out of the box. So what's wrong with that story? What are the problems in text to SQL?
I can take up that briefly and others can chime in. So when we are talking about text to SQL as a use case for enterprise domain, the problem with text to SQL is that in most cases, users when they're interacting with these databases and they want to get some data that they need, they make these queries in natural language, and often they are themselves not really sure exactly the data that they're looking for. And they end up making some ambiguous queries, which leads to different possibilities. Like there can be different interpretations of those queries, and can follow a particular interpretation or assume a particular interpretation and generate the SQL, or the agent can generate the SQL in this case. But it's not very easy to exactly generate the SQL as per the intent of the user. So identifying the correct intent becomes a challenge in this case. And that's where, like, even though even the frontier models have made great progress and code generation, they have been shown to do quite well. But I would say text to SQL is a much more complex use case where sometimes these frontier models can struggle if we do not model them correctly or if we do not resolve the ambiguities.
Yeah, to echo what Ian said, it's kind of like there are two separate kind of but related problems. There's the code generation problem, right? writing correct SQL. And that actually, the GFMs do extremely well at out of the box. But then kind of prior to that, there's the kind of query understanding in context problem, which is where the real meat is at. And there, the GFMs kind of don't do well out of the box.
So let's dig into that a bit more. So when you say the frontier models are not great at the context understanding part of the problem, say a bit more. What exactly do you mean, and where is the breakage?
Yeah, so I can mention a few things and others can join in as well. But often the user's natural language kind of statement of their request or query contains perhaps terms that might refer to multiple tables or columns in the data context, or terms like recent or current, which are open to multiple interpretations, which could be guided by the data context itself, or might require kind of, the human to clarify their intent. I'll let others jump in with other examples of that.
Also, like I feel that when we are trying to do text to SQL and there are multiple dialects involved, meaning that we can generate the SQL in Snowflake or in BigQuery and also in Postgres and other dialects as well. It becomes highly challenging to really like generate the correct SQL for a particular dialect, and particularly for more complex dialects, for like Snowflake as an example, because there are a few nuances that are specific to a particular dialect, which may not exist in another dialect. So for these agents, generating the SQL might be more non-trivial for some of these complex dialects compared to well-known dialects, like for instance Postgres. So we have observed that generating SQLs correctly in the Postgres dialect is much more or is less challenging for these agents compared to dialects like Snowflake, for instance. So that also is another dimension where the challenge arises for these agents.
Yeah, that makes a lot of sense. And I can see how the problem of generating SQL is a bit different than the typical vibe coding problem that a lot of us are used to, where, we can vibe code, say, an app in Python or TypeScript, and that's different than taking a natural language utterance and mapping it to like tables with maybe cryptic column names, and even selecting the right table from maybe hundreds of tables that a company already has. And so I think all those together make it a much more complex problem compared to simply generating code, because there's a ton of existing enterprise context you have to understand. Before we get into the benchmarks themselves, do you want to talk a bit more about the typical enterprise use cases? What kind of users are you targeting? How is this situated in, say, a larger agent or a larger workflow?
How about I take a shot at framing this on a spectrum from BI and ML to defining systems that involve access to data in whatever business process or workflow, because those are two different things. So first, let's define the spectrum of use cases. At one end, we have someone exploring, seeking insights, potentially discovery, or maybe somebody operational interested in overseeing and drilling down into data related to operations. That's much more dynamic and exploratory. On the other end of the spectrum is the cascade of people and work involved in developing information systems in accordance with requirements directed at meeting business objectives. In that context, you're going to do a variety of code generation, potentially including agent definition, and you have more time. That's an offline activity. You have more time, and you can spend more inference and exploration to get the code you generate right, including the SQL you generate, reliable, tested, performant, etc. I'll pause there. What do you think?
Yeah, so that's kind of the full spectrum. Maybe you can talk about like what are you seeing most commonly in the customers you're talking to, and like specifically how now that you have agents that can do much more than traditional BI, or maybe even if it is traditional BI, it becomes a bit more democratized because you're not always waiting on, say, your in-house technical team or your in-house SQL expert. How does that change the scene?
At Emergence, we're actually active at two ends of that spectrum. At one end, when we talk about talk to data, we're primarily talking about read access, potentially ETL, but where we might write or define some database that's more efficient for some purpose, but we aren't going to modify, we aren't going to alter an existing database, we're not going to update, insert, delete, or whatever that database. So, and that end of the spectrum is the BI and the ML end of the spectrum, because what you're primarily interested in is getting data either to respond to a query or to populate, for example, a machine learning, or to employ some other algorithm, potentially, optimizing problem solver of some kind. You just want to get the data and feed it, and you're not going to alter the data. So you're safe. You don't have side effects. That's one end of the spectrum. And there, that's very dynamic and interactive, and that's primarily what we've discussed so far. At the other end of the spectrum, where you might even go as far as allowing the agent to insert or update data into operational databases, you need to be very confident, extremely confident, that not only the software you've generated, but the actions that agents or software may perform that will alter data is reliable, performant, etc. Right? You got to do that. So over in that end of the spectrum, we're working comprehensively on working down from requirements into verifiable code generation, ultimately including verifiable SQL operations that update or alter databases. And we're doing that with various degrees of formality, bottoming out in theorem prover technology so that we have essentially a logical / mathematical guarantee that what we've generated in terms of code or agent definitions meet the requirements. So Emergence is taking two unique approaches at each end of that spectrum.
Maybe another thing we can pick up is there's really kind of a yawning chasm between what the text-to-SQL benchmarks are designed to evaluate and the type of dynamic, business relevant, nuanced processes that Paul outlined there.
So that's great background, Paul. And Jeremy, what you're saying is, yeah, I want to move to that because that's a great segue into talking about benchmarking and more of the specifics of what you all did on benchmarking. But yeah, Ayan, I thought you were saying something. Go
Yeah,
ahead.
just to add to Paul and Jeremy's point, but from a slightly different perspective, but it might be related as well. So what I feel after working on text to SQL for the last few months and working with the benchmarks is that like it is one thing doing well on one or more of these benchmarks through developing an agent that works well for talk to data text to SQL. But it's a slightly different thing in terms of when we want to have that as a product, like from a productionizing these agents. The difference is that, like in case of a product, we should be aiming for coming up with a solution, text to SQL solution, which is more generic in terms of its ability to generate SQLs or produce answers from those result of those SQLs that caters to the user's query. So the system needs to be as generic as possible. Whereas when we are trying to do well on one of these benchmarks or set of these benchmarks, in a way, we are trying to optimize this agent to do well on a very small subset of use cases, which is the danger of like over over specializing the agent that we develop. Whereas from a product point of view, I think the objective should be that we develop a solution which is as generic as possible, and it should not be expected to work only for a few databases, but it should work across the board for many databases across different domains. And that's what I wanted to share in this context.
Yeah, makes sense. You don't want to overfit. All right, so that's a great segue. So let's talk about, yeah, Pralhad, go ahead.
Oh no, I also wanted to bring to the fore some newer use cases, right? And emerging use cases, like for example, talk to your database from Slack, let's say. And that's a very different scenario, right? Because this may not be a one-to-one conversation, right? You are the only one talking to this database, and the database is responding to only you. Your response is being seen and observed by everybody in the channel. So that makes it a very interesting situation where the response is to be catered to everybody in the channel, right? So this is a very different scenario, and most people probably don't think about it as a non-traditional situation. But increasingly, I feel like something like this, these kind of considerations need to be also be taken into need to be incorporated when we think about designing agents and so on and so forth.
Just
100%.
let's take a little bit of another offshoot here. In Spider 2, we often have queries, or what they call instructions, basically a paragraph in some cases, laying out what the user wants. And that paragraph is full of ambiguities. We won't get into that. I'm going to say that that's not a realistic scenario in the enterprise. In the enterprise, you're going to ask a small question. Then you're going to refine that question. And then you're going to tack on something else because you want to make sure that the AI is with you. And by incrementally refining your query, you avoid much of the ambiguity, or you make resolving that ambiguity simpler on a turn-by-turn basis. And it's very difficult to formulate just think about it. Can you imagine typing in a 50-word question as your first question for your database? That's not a realistic thing. So the benchmarks, like Spider 2, go too far in laying out complex queries in paragraphs. And they need to go that far to stress the capabilities of the underlying SQL generation agent, because if the queries are trivial, it's too easy. And we go back to things like Bird SQL, which is a much simpler set of queries from users, and it's much easier to nail those. But that's more realistic if you put it in an iterative context. So the benchmarks trying to stress code generation, SQL generation, etc., are artificial versus real use cases.
And in doing that, they've obscured what is actually the hard and interesting part of the problem, right? The part that comes before the SQL generation.
True.
Yeah, so that's a great segue into this next part, right? So you talked a little bit about Spider there and why benchmarking is hard. So I want to continue with that thread. So yeah, talk a little bit about the main benchmarks in this area and then Spider specifically, because you all have done a lot of work on kind of improving and modifying Spider, and then I want to get to that new benchmark you all have put out. But let's start by just describing for the audience what is Spider, what it tries to capture, and then how you saw some areas where it could be improved.
So Spider 2 is an extremely difficult benchmark, right? Previously, Paul and Jeremy have been working even on Bird and Spider 1, and those were simpler, right? Spider 2 ends up being extremely challenging. And as Paul was referring to, there are several questions which are like 50-word questions, right? And you would not expect such kind of difficult questions up front as the things to solve, right? But even though it leads to it's an interesting technical challenge to solve these kinds of questions, right? Right. And the point is, what techniques can you come up with to be able to resolve these ambiguities, identify these ambiguities, resolve these ambiguities? What options do you have? What resources do you have? Can you ask the human? Can you probe the database? Can you look at the past solutions that you have done about how you have resolved ambiguities and so on, right? So these are all the options that you have. And in exploring all of these options, there's significant learning, right? So I really enjoyed working on Spider 2, and we did find some issues with the benchmark, and we have put out a blog, and in that blog we have called out the issues, right? So for example, there's some data drift, right? So what happened is, how we observed this first is, there's some training data available, and our expectation was that so this training data has SQL and ground truth result CSVs, and our expectation was that for all of the training data we would see exact matches with the result CSVs, right, that were provided. But we found that there was some gap, right? And this led us to further investigate whether, this sort of pointed to a data drift, that the underlying data might be changing and so on and so forth, right? And so we were able to do a lot of preliminary work and solve many of these Spider 2 questions, but we were also able to very conclusively identify several situations where in the test set as well, there's a clear evidence of data drift and so on, right? So that is one. And there are also other issues around, I think for several of these cases, the result sets were acquired on BigQuery, right? And then the data was moved onto Snowflake, right? And so there are interesting differences between how SQL is processed in BigQuery versus Snowflake. So the SQL engine differences also sort of create some issues and discrepancies in how in the results that you see, right? So these kinds of aspects we have highlighted in our blog, and we have also proposed a new blog which we call Spider 2E, and this has a slightly, we have removed some of these queries which have data drift and engine issues and so on, and it's a better benchmark in that sense, right? And more, perhaps Ayan is more suitable to talk more about Spider 2E and so on.
Yeah, that's a great overview, Pralhad. So, yeah, I do want to get into Spider 2E in a bit more detail, but real quick before we do that. So, you pointed out several kind of issues with Spider 2 in terms of data drift, and I know the blog post also talks about how result only evaluation is too weak and doesn't capture the full nuances of what's actually happening in this problem domain. So can you talk a bit more about those things, those concepts that the benchmark isn't quite yet capturing? And then we'll come to how Spider 2E tries to address those.
Yeah, yeah. So I think, and Ayan, you should feel free to add to what I'm saying here, right? But things like, if you are, let's say, I think benchmark should be more descriptive of, what are the expectations from an agent, right? So are you supposed to do this and get these answers in one shot, for example? Is it okay for you to generate SQL, then compare it, generate a result, compare it against, the gold results provided, and refine your SQL generation and so on, right? So these are things that need to be stated upfront. I don't think they were stated in the benchmark about the expectations of an agent, right? Because it's quite possible that several of these agents are iteratively improving their answers, right? And there's no, we don't know if this is allowed or not, right? In a natural setting, if you want to use this information to build a product, then you should expect a one-shot answer, right? But it's not clear from the benchmark what their expectations are. Secondly, what we have seen is that agents tend to overfit in a weird way. They can end up copying the answer and giving the answer straight out, as opposed to like generating SQL and so on. Right? You could be seeing the exact response that you want, except that it is not even like generating a proper SQL and so on and so forth. Right? So if your evaluation mechanism is not detecting for these kind of things, then it falls short, right? And so the eval scripts that have been provided by the Spider 2 maintainers, they lack these abilities to detect these kinds of things, right?
So yeah, I would like to add to what Prahlad mentioned here, and the particular case that what Prahlad was talking about. So this is a case of an hard-coded SQL that is generated by the agent, and this also ties to what I was speaking a while ago, which is when we are trying to do well on a benchmark, the agent tries hard to overfit to that benchmark to get, to get SQLs that match the cold results. So in doing so, we found, interestingly, we found that there was one SQL that was generated by our agent, which was basically a hard-coded SQL. We were not aware of such a SQL, such a type of SQL that could exist. Like actual values from the result were included in the SQL just in order to match the result. That was a weird case where the agent tried hard to overfit. I would like to also mention about a case where if we go back to the earlier days when we were exploring Spider 2, and I think Jeremy and Paul were also involved in doing that, we kept on trying different approaches. I remember we started off with a single step approach where we tried to fit in a single prompt to generate SQL directly from the natural language query. Then we moved to more sophisticated approaches like multi-step SQL generation, where we brought in planning steps and then intermediate SQL generation steps, followed by assembling all the intermediate SQLs to get the final SQLs. But while in doing so, I think one mistake which we were making is that we were working with these benchmark data sets. We relied almost blindly on the evaluation scripts that they have. What we were trying to do is that we were trying hard to match against the ground truth results. But we didn't, we realized later on when we looked at the individual cases that it was not that our agent or our framework that we built for text to SQL, they were generating wrong SQLs given the input natural language query or the database schema we had. But the fact was that because of the ambiguity, and this ties to those 50-word examples that we have in this Spider 2 benchmark, these queries were so ambiguous that there were multiple valid interpretations, and possibly the benchmark code was following one interpretation, whereas in our case, our agent was following a different interpretation that was also a valid interpretation. And when we tried to match against the code, we were getting the wrong signals. For instance, we were in that zone of, we were hitting a ceiling of 50 to 55% of accuracy in terms of matching with the cold results. So we were kind of hitting a trough. And at that time, Prahlad and I came up with the idea of building an in-house evaluator, which was kind of an LLM as a judge kind of evaluator. And I think that was the first indication where we saw that. So this LLM as a judge evaluator, what it did was that it tried to score this agent generated SQLs on a scale of 0 to 100 in terms of the correctness of that SQL, given the actual natural language query and the schema, database schema that we have, the tables in it. And we've actually found that the agent was generating SQLs which was mostly correct. Correct means it was giving a score of more than 90 for almost 80 to 85% of cases, as opposed to 50 to 55% accuracy, which we were hitting in terms of that trivial evaluation given by the Spider 2 folks in that benchmark. So that was the first indication that, yeah, this benchmark, the evaluation methodology that they are following might be flawed. And we need to perhaps challenge this benchmark or find out issues that could exist in some of the ground truth results that are there. And I think Paul has also parallelly done some investigation, and I think quite a few cases individually where he also seems to share the same point of view about our sequels being better than the sequels that the Spider 2 benchmark has provided as ground truth. So yeah, like there were these indications and there were these experiments that we did, which led us to believe that this benchmark, there could be issues with some instances that are shared as part of this benchmark. And we needed to provide some corrections to this.
I'd like to follow up on that a little bit at a high level. So you're given one of these big queries, lots of words, and you can look at the results and give an agent the results as a target and let it chase the results, and it'll get there. And hopefully it won't cheat by putting the answers in the SQL, which we were just talking about. But stepping back from that, let's just think abstractly. Is the benchmark SQL or result set good? Is it right or not? Well, it's given, but that doesn't mean it's good. So what we can do is we can let a pipeline or some tool generate SQL, and then we can get that result set, and we can look at, okay, here's this effectively the SQL is the net of the interpretation of the query, and the result set is what you get. And you say, oh my gosh, they're not the same. The result sets aren't the same. Now, you may or may not have the SQL from the benchmark. There's only a fraction, what was it, about 20% of the queries had SQL or something like that, in Spider 2, something like that. So for that other 80%, you're just trying to rationalize, well, wait a minute, is my result set better than their result set, or is their result set better than mine? That's not an easy problem, but you put a human in the loop with a language model and you discuss, here's the question, here are the results, here's the database, here's the SQL, and you often find that, oh, well, I figured out how that answer was generated, and Pralhad did something that was great at reproducing those answers. That's how you get to 95% on the benchmark. You look at the answer and you figure out how to get it. But that doesn't mean it's right. And so we looked at roughly 100 such differences between our product and what the benchmark had. And in the vast majority of those cases, the benchmark's inferior. The benchmark calculates poorly, it queries poorly, it's got answers that are not very good compared to another technique. And that's a stunning result, right? That on the order of 100 questions in this database are just not that well answered. And it shouldn't be a surprise because these are complex queries. Somebody had to figure out how to do it. And they're complex enough that even a human isn't going to be perfect. And however they generated these results, a review of that might say, oh, that looks right to me, but not actually be right or not be optimal for the given query. It's just tough to produce a benchmark like that. So my point really comes down to this. There's a space of interpretations and implementations in response to a complex user input. And if you look at one product of that and say, that looks good to me, that's hardly a robust way of benchmarking because there might be 5 other products that are better. So this interpretation space, this implementation space, and I'll go back to my earlier comments about some implementations are better than others. For example, if they leverage indexing and sargeability well, that's a better query than that query. None of that is considered in these kinds of things. But the intersection of interpretation space, so you have the potential interpretations of someone looking at the question itself, and then you have the interpretation space which is resolved in one way by the benchmark. the intersection of those is not trivial, and it's hard to produce that benchmark that in a large interpretation space has the best one.
Yeah, so that is great background and motivation, and you all have kind of channeled all that into creating a new benchmark or a fork of Spider 2, and you're calling it Spider 2E. So can you talk in a more specific manner about the main differences between Spider and Spider 2E? And you've put it out as a GitHub repo. We'll leave links to all that in the description. So yeah, what you just talked about kind of sets up why you need a new benchmark in order to address some of these shortcomings in the existing benchmarks, specifically Spider.
What I just talked about with the interpretation space and the a superior result versus a benchmark result, that we haven't addressed and will be very difficult for anybody to address in a benchmark. You could put forward what you think is a superior implementation, a superior SQL, a better result set. You could put that forward, but representing that that's the best that there can be and that somebody else won't actually find a superior alternative to yours, that's a difficult problem. And I don't fault the benchmark creators for having an acceptable, if not an optimal, result in the benchmark. It's difficult to put out a benchmark where you would represent that your results are the best and proper.
Yeah, so primarily we have three contributions when it comes to Spider 2E, and I would like Ayan to speak more to it. But at the high level, there were a bunch of data drift cases, and what we were able to see is that this data drift itself is ongoing. For example, if we execute the same SQL today and tomorrow, we would see different results. Okay, so it's an ongoing data drift, and we are talking with some live databases, live data sets, as opposed to snapshots of data sets. So that's one issue. So we, in Spider 2E, we have removed these, right? So these queries which are hitting these live databases with ever-changing results, we have removed those. The other thing is that in some cases we could sort of add corrected versions, right? When we were able to see that the SQL engine differences were there and that is causing some problems, we were able to add some corrected versions of the SQL. And finally, we also worked on the evaluation system, right? As we previously described, the evaluation mechanism was very simple and very results oriented and did not cater for detecting any hard coding and things like that. So we improved upon that. We added a new evaluator which also detects hard coding and so on. So I'd like Ayan to describe this a little bit more.
Yeah, to add on from what Pralhad mentioned, I'll go a little bit into the specifics of Spider 2E. It is a corrected version of Spider 2, specifically the snowflake split of the Spider 2 benchmark. So, what is the difference of Spider 2E from Spider 2 is that in Spider 2, for instance, we had a total of 547 instances which belong to that snowflake split. And we removed a total of 23 instances from that benchmark. And instances were problematic in one way or the other. So some of these were data drift cases, which meant that uh, these belong to databases. The queries were for databases which were live Snowflake databases, which means that there are changes to the underlying data. At different points in time, we'll find different snapshots of the data within the database. And that's because new data is added to this, or there are refresh counts, or there are rolling time windows, and there are other similar kinds of cases. And due to which, like even if the SQL, let's say direct SQL provided by the benchmark is correct, if we execute that SQL at a different point in time, it will not match the cold results that are provided by them. So even interestingly, while we were preparing this corrected version of the benchmark, Spider 2E, Ourselves, we found that we also had our agent generated SQLs. And the agent generated SQLs actually gave us different snapshots of the data, which couldn't match the ground truth. But while preparing this blog as well as this benchmark, when we tried the same query generated by the agent, after a few days, in a matter of days, we found that it doesn't match our old result. So that's where we realized that these live databases are problematic and claiming that there's a single gold result that needs to be matched in order to achieve success on the benchmark. That's where, I mean, the pitching of that is somewhat, I would say, a bit problematic or flawed in with respect to what Spider 2 has claimed in terms of like opening up the benchmark for different leaderboard entries. So yeah, as I was going into the specifics, so out of these 23 instances, we found a few of those, like three of those instances were cases where there were queries which pertain to databases which were revoked. So probably these were some proprietary data that were made available as part of that benchmark by Snowflake. Later on, these databases were revoked or access was, I mean, removed for these databases. So for those cases, we couldn't execute the SQLs that we were generating on the respective databases, and hence we thought that we need to remove those instances because they should not be part of the benchmark because no one could really verify any SQL without execution if the database is unavailable. So three instances were related to database revoked cases. The remaining 20 ones were primarily the data drift cases, which I discussed in some detail already. So these were part of those live databases. So we also removed those instances and we found that there's no way that someone can match the cold result, given that there's such dynamicity involved in those instances. So apart from these 23 instances, so in Spider 2e, we are left with, if we remove 23, we are left with 524 instances. But even among those 524 instances, there were five instances where we made some changes because, as Pralhad mentioned, these were cases where there were some differences in terms of the execution results of the same SQL because of the engine differences between BigQuery and Snowflake. So basically, for these instances, these were initially executed on the BigQuery databases. But as part of the benchmark, Spider 2 guys have transformed those to the data to Snowflake databases. And hence, when we execute the same gold query, we do not get the same result or because of these engine differences. So there were these five cases for which we generated the correct SQL for using our agent and we added that as a new gold variant. So we added an additional gold variant claiming that this one is the right gold variant of the SQL, claiming that this one is the right SQL for the Snowflake dialect. And those are the changes that we made for these five instances. And finally, what we did was that eval script had some issues. So there were some trivial checks in the eval script, which involved like if there is an exact match, they will score that as a success. Otherwise, they will score that as a failure. However, they didn't consider two specific scenarios. One is the case where, let's say, we generated a hard-coded SQL. Now, if the hard-coded SQL on execution matches the gold result, the eval script will consider that as a success. But actually, the eval script is unable to identify these hard-coded cases, and these should be marked as failures. So what we did was that we modified the eval script so that if there is a hard-coded SQL, it should by default flag it as a failure, even before checking whether it matches the ground on execution matches the code or not. And the second scenario was that it was a very simple case which the eval script was missing, which was like if, let's say, there's an empty result set in the code and we generated some SQL which on execution also produces an empty result set. So ideally, this should be a success. But because it's an empty set, the original eval script by Spider 2 was flagging this as a failure without matching with the old. So this was a case where, given the SQL, it was, or the given the query, it was not matching any particular data in the database, and that's why it's an empty result set. So we took care of these cases to match. If there's a match with the code, we flag this as a success. So these were few changes as well we did to the eval script, in addition to removing or adding instances in Spider 2E. So roughly, this is what are the main differences between Spider 2E and Spider 2. And we believe that this is a corrected version, which is devoid of the issues that we found in Spider 2. But yeah, there could be these cases where like there are multiple interpretations, but we followed one particular interpretation. The other interpretations might also be correct, but we didn't consider those. Yeah.
So what Ayan just mentioned about adding evaluation of the SQL itself in addition to evaluation of the result set is an important contribution. Okay. But benchmarking is hard. It's complex. It's difficult to get this right. So by no means are we criticizing anybody who's provided any of these SQL benchmarks. But I'm going to touch on a couple of other issues that we haven't resolved but definitely exist and are a challenge to creating a good benchmark. So I'm going to give you three. One, there's a question that asks for the zip code with the most of somebody who does this or whatever it is. And the result set comes out and it looks beautiful, but the evaluation fails because the zip codes are rendered as strings instead of integers. Who would have thought to render a zip code as an integer other than the benchmark? But it's plausible, I guess. But to say that's wrong, so anybody who got that right in their submission to the benchmark either targeted a zip code as an integer or they got lucky. Okay, so again, if you expose the result set to a tool calling agent pipeline, it's going to try hard to get you there, and it'll figure out not to quote the zip code. But is that relevant, or is it actually better to quote the zip code? Good question. I'm not going to take a position. Second thing, so query is something like, in the last quarter, how many were there? And guess what? It depends what quarter today is in. And so when they ran that in 2024 or whenever, they got a different answer than if you run it today. You got to get that out of the benchmark. That's tough. You got to do a lot of analysis to make sure there's no, what do you call those references? Dietic or something like that? In the what?
Deictic.
That whatever that word is, yeah. And then a third example, very common, is the user asks for some information, and you can present that in a number of ways. You can present it with a lot of columns, or you can present it with a lot of rows. It's like pivoting the answer. And there might be multiple such pivots. So if you're hitting a benchmark that's got a lot of pivots in the potential response space, again, you're targeting the benchmark and penalizing somebody who gets the semantic response perfect, but it doesn't meet the structure expected by the benchmark. That's a flaw in the benchmark. I don't want to say it's not a good benchmark.
So I guess the way I think about it is benchmarks make several different types of contributions, right? One contribution of a benchmark is just the set of examples, like the raw data. Is this a good kind of playground to test and prove your systems? In this case, kind of talk to your data or text-to-SQL systems. And then separately, the benchmark is also contributing some evaluation procedure. That can include ground truths, can include scripts for running evaluations. And then the third thing maybe that benchmarks are kind of contributing is some assumption that the kind of task that the benchmark is measuring is actually kind of analogous to some real world task that, the benchmark claims to be relevant to. And my judgment is that on the first measure, Spider 2 is super valuable. It's a great collection of examples that has been really useful for us in kind of developing our talk to your data text-to-SQL systems. On the second measure, the evaluation procedure, there are a bunch of issues that others have explained really well and that we've tried to identify, isolate, and put out this new benchmark that addresses them. And then on the third issue, does the actual task align with real world tasks that it claims to measure? I think there are some deeper disconnects there. We need to rethink, as Paul was saying, what the true task we're measuring is. Is it just text in, SQL out? Or is it this more involved human in the loop process where we're disambiguation as a first class kind of citizen here? That's my take on Spider.
Right, right. And I suppose that's the age-old problem of benchmarking, which is that you need the benchmark to abstract somewhat from the real world and be general while still being representative enough of the real world domain or problems that it's trying to benchmark in the first place. So that's a fine line to walk. All right, so I think that was pretty good coverage of the background and the benchmark.
I found that working on these benchmarks, and specifically Spider 2, given that it had a few flaws and issues, but today, after working with this benchmark, I seem, or we as a whole in the company seem to understand the text to SQL problem much better now. We understand what are the challenges of doing text to SQL, and there are a lot of learnings that we are carrying forward, which if we can share with whoever is building the product, they will greatly benefit, or maybe we can tell them that they can avoid few things while building this product, and sharing these learnings will help them immensely. For instance, like I think the work that Pralhad did while building his agent to generate SQL on Spider 2, the skill of ambiguity probing or ambiguity analysis, I think that's a very important step. And we actually found in our experiments that doing ambiguity analysis actually helps the agent to be more clear about what's the intent of the user is while generating the correct SQL. And also, the other thing I found is that, yes, Spider 2 provides a good repository of databases. Like these databases are very rich. The queries are also rich, but they are not always realistic. That's my concern about the queries. But we can generate a lot of realistic queries from these databases, given the richness of the schemas that are prevalent in the databases provided by Spider 2. The only complaint I have about Spider 2 is that maybe all these text to SQL benchmarks is that, and I feel after understanding this text to SQL problem better now, is that all these methods have looked at like quantifications or looking at exact matches, like quantifying whether there's a match between a ground truth and some predicted artifact or not. But I think there needs to be some measure of whether there's semantic alignment of the SQL, the generated SQL, or even the result with the actual query the user asked. So it may be difficult to come up with a metric. It is really hard to come up with a tangible metric which gives us a measure of the semantic alignment. But that's the gap that needs to be cracked to come up with a very robust evaluation criteria for text to SQL in general.
Yeah, that's a great point. So definitely very rich ground for future work. Spider 2E sounds like a great contribution to the field in terms of providing a more realistic benchmark for text to SQL. Like I said, we'll leave links to all this in the description. And that sounds like a great place to wrap up. So thanks very much, folks, and we'll see you in the next one.